Okay, so this video is for my Algebra 2 students, come from CVCC. We're going to have a quiz on Thursday over exponentials and logarithms. So this video will do a good job, of reviewing those topics. It might be 2 videos, because I have several problems I want to go over. So it might be 2 videos, but we'll just wait till the end to see. Alright, so here is the first problem. Okay, so we're going to graph these. Alright, and we're going to look at part A. A says y equals negative parentheses 1/3 raised to the x minus 1 power plus 2. Okay, so there's a couple things. This is an exponential graph. The first thing, we look at our b value. Our b value is 1/3. That's less than 1. This is going to be a decay graph. So that means on the right side, it's going to go towards the asymptote, wherever that is. Okay, it's going to go towards the horizontal asymptote. I would like you to indicate the shifting. The shift here, this minus 1 means to the right 1. This plus 2 means up 2. So my asymptote is going to shift up 2. So instead of being at the x-axis at 0, it's going to be at y equals 2. And now I want to find the y-intercept by plugging in 0 for x. If I plug in 0 for x, and I let my calculator do the work, and it comes out to be the nice answer of -1. So your x-intercept is going to be at 0, -1, 0, -1, 0, -1. And now it's going to be decay. So to the right, it's going towards the asymptote. I could do better. There we go. And to the left, it's going away from the asymptote. And there's your exponential curve. Now notice your asymptote was here at 2, and your y-intercept was below it, which means that this graph gets flipped upside down. Well, what does that negative mean in front? It means x-axis reflect. And that's exactly what we did. Last thing I want is the domain and range. For an exponential, the domain is all real numbers. The range is where this graph goes vertically. Well, it stops at this 2 and it's everything below. Well, below means -infinity, so that has to go first. -infinity up to 2. We do not include 2 because it's an asymptote and this graph cannot touch the asymptote line. So there's our exponential graph. The next one you see is a logarithmic graph. Okay, so for logarithms, there's no growth or decay. We just first identify the shifting. Plus 3 inside means to the left 3, and minus 2 means down 2. So our vertical asymptote will now move to the left 3. Let me use a darker color. It's hard to see. Blue's better. I'll go between blue and orange. And there's our vertical asymptote at x equals -3. I'm going to plot my point. Now, remember, the point that's on all the graphs is 1, 0, so we need to move it. Well, I'll show you the movement. You use the h and k for the movement. 1 minus 3, 0 minus 2. You do what this says. It says minus 3, that means go to the left 3, subtract 3. So your point 1, 0 is going to become -2, -2. And that's the point I'll graph. -2, -2. There is nothing out in front, so there's no reflection. So this graph goes towards the asymptote down and away from the asymptote this way. Just like that. And there's your graph of your logarithmic function. I need the domain and range. The domain here starts your asymptote and goes to positive infinity. That's -3 to infinity without the parentheses. The range down to up, all real numbers. And there's the graph of an exponential and a logarithmic graph. Okay, here is our next problem. I'll read it to you. Hopefully you write this down. In 1980, wind turbines in Europe generated about 5 gigawatt hours of energy. Over the next 15 years, the amount of energy increased by 59% per year. Write a model and determine the amount of energy generated in 1984. Okay, so you need to understand that this word increased is important. Increased means growth. This is a growth model, and we have to use the equation y equals a 1 plus r to the t power. Okay? So y is the amount of energy, so that's what we want to find. So y is y. A is the initial amount. Well, it generated 5 gigawatt hours in 1980, so that's your A, 5. The rate is this 59% written as a decimal, 0.59. So 1 plus 0.59 is 1.59. And then t. This is your model. Okay? So again, this r is 0.59. It's the percent. This is your r. So we write it as a decimal and add it to 1. So now they want the amount of energy produced in 1984. Well, if you go 1984 minus 1980 when it was started from, you get 4. And there's your t value. Y equals 5, parenthesis, 1.59 raised to the 4th power. And the calculator does it all for you. 1.59 raised to the 4th. I'm going to say 32. About 32 is the answer. And that's 32 gigawatt hours. And there's the amount of energy produced in 1984. Growth model. Remember, there is also decay, which is like decreased, and that would be a 1 minus r. Okay, so here's our next problem, a compound interest problem. You deposit $1,600 in a bank account with an annual interest rate of 2.5%. Determine the account balance if interest is compounded quarterly or continuously. And I forgot to tell you how many years, so we'll write this down. And we'll say determine the account balance after, we'll go 5 years. After 5 years. Okay, so I forgot to do that. Make sure you put that in there. Determine the account balance after 5 years if interest is compounded quarterly or continuously. Okay, so we do need this formula. When it says quarterly, that's going to give us an A value, so we need the formula, an N value. So we need the formula A equals P 1 plus R over N all to the NT power. Okay, and we have to be able to identify our parts from here. Well, A is the account balance, that's what we want to find. P is the principal, which you start with, 1,600. 1 plus R is this rate. Move the decimal twice over, that's 0.025. N is the number of compoundings. Now quarterly means N is 4. All raised to the 4 times T, and T is the years, that's 5. So as I instructed you in class, figure out what some of those numbers are. Don't try to plug it all in at once because it's very confusing. So I figured out what this is, and I'm going to figure out what that is first. So A equals 1,600. This came out to be something very nice and even, 1.00625. And 4 times 5, this is times, is 20. So now type this in your calculator. It's a lot easier. 1,600 times 1.00625. all raised to the 20th power. And I get, rounded to money, 18, 12, and 33 cents. So in that 5 years, I got roughly $200. Now that's quarterly. Now, if you see this word continuously, you are supposed to remember a different formula. A equals P e to the RT. It's that APERT formula. Continuously, it's that maximum you can reach, that limit that you can never attain, but here's what it would be. It involves this E. So we use some of the same numbers. P is still 1,600. E is E, the number E. R is that rate, 0.025, and T is still 5. Notice there's no N because there's no compounding. It's continuously. It's done all the time. So get what that power is. 0.025 times 5 is 0.125. And now type it in. 1,600 e to the 0.125. I get 1813.04, so 4 cents. And that is the maximum possible amount that you can get for this compound interest problem. All right, and notice it's bigger than the quarterly one. Okay. Okay, here's our next two problems. These problems say simplify, and this is where we treat e like a variable. Okay, remember e is a number, but it can also be treated like a variable. So the first problem says e to the 4x, that's an x right here, that numerator squared over e to the third. So the parentheses are not around the entire fraction. Okay, so this squared only applies to the top, and what we do with these exponents is we multiply. E to the 8x over e to the third. And now you have the same base, top and bottom, e on top, e on bottom. Take their exponents and subtract them. On the side here, 8x minus 3, and you might be confused and say, hey, maybe this is 5x, but it's not. It does not equal 5x because this 3 has no x. 8x minus 3 is 8x minus 3. You just leave it alone. That's the exponent of your e. And there's that problem simplified. Okay. Okay, next one. E involved in a radical. You have a square root. Okay, the index here is 2. It's not written. This is a 2. But it's not written. You never see it. So we need things that are squared inside here. Well, 36 is 6 squared. And what can I square to get e to the 10x? Well, remember, you're going to multiply your exponents. So the question is, what times 2 gives you 10x? You know, it has to be e. Well, I think 5x times 2 will give you 10x. And that's true. So what happens? The 6 comes out. 6 squared goes away. The e to the 5x comes out, and that squared goes away. Nothing's left inside the square root. You are done. Okay. So it's that tricky part where what squared gives you e to the 10x. But just put a parenthesis, put that squared on the outside, and ask yourself, multiplication. What multiplies by 2 to get 10x? Okay, here are the next two problems. We're getting into logs now. Simplify these two logs. Or, you know, what it'll actually say, I'm sorry, it'll say evaluate. And remember, anytime you're trying to answer a log problem, the answer is going to be an exponent. You need to remember this. Logs are exponents. That's exactly what they are. Okay? So we're going to rewrite these problems. The first one, log base 4 of 1/2. We're going to write it as 4 to some power gives me 1/2. Okay? Well, it'd be nice if we could write this in base 2 terms, right? So 4 is 2 squared. So 2 squared raised to what power gives you, and 1/2 is 2 to the negative first power. So the question is, 2 times what gives you -1? Compare these exponents. You're going to multiply here, and you need to get a -1. Well, I think if the question mark was -1/2, then you would get -1, because 2, check, 2 times -1/2 gives you -2/2, which gives you -1. And that's exactly the exponent I wanted. So your answer to this problem, the question mark, is -1/2. 4 to the -1/2 gives you 1/2. Okay. Next one. Over here, log base 125 of 5. Again, we take 125, the base, to what exponent gives you 5? Well, here, you're taking a big number and making it smaller. So, potentially, you know, we need to use either a negative or a fraction power. Okay? Well, let's write this in terms of 5. 5 cubed to what power gives you 5 to the first? And again, what does this question mark have to be to get you a 1? 3 times what gives you 1? Well, I believe the question mark is 1/3. And if you check, 3 times 1/3 is 3/3, which is 1. And again, that means that you need to take 125 to the 1/3 power. But we should know that the 1/3 power is also the cube root. And we should know that the cube root of 125 is exactly 5, what we wanted. So there you go. So those are the trickiest kind. Some of them the other ones are more straightforward, but these are the tricky ones, so I put them on here. Okay, 2 more problems left. So this one is truly a simplify because you have an x involved. You might not necessarily get a number. Alright? Well, we have to remember the inverse relationships. Do you remember here that if you have log base b of b to the x power, you're going to get x. And if you have b raised to the log base b of x power, again, you'll get x. So it's these inverse relationships that you have to remember. Well, let's try to figure this one out. Now, this problem, there is no base written, but do you know what it is? You should. This base is a hidden 10. Remember our number system. If you see log with no base, it's a 10. So the question is, can I make these two numbers the same? Well, I think I can. I think I can rewrite 1,000 as 10 to some power. 1,000 is 10 to the third. Right? It's a 1 with 3 zeros. 10 to the third. And now I can simplify this parenthesis by multiplying your exponents. And there we go. And now do you see this relationship right here? It's right there. Log base 10 of 10 to the 3x this time, though, not 10 to the x, 10 to the 3x. The log base 10 and the 10 will cancel. And I'll get 3x. So remember these two. These are the inverse relationships. Inverse. So remember that idea. Okay, one more problem. Okay, so we're going to find the inverse of this function. And notice that this function is a natural log function, so we should know that the inverse of a natural log is going to be an exponential. So I'm looking for an exponential. Now, the first thing is, make that a y, swap x and y. And then we had this discussion in class on Tuesday. This I want to get by itself because I want to rewrite it in exponential form, but I have to get the log by itself. This y plus 4 is with the log. This 2 is not. Get rid of it. So on this side we get x minus 2 equals the natural log of y plus 4. Now I can rewrite it. This has a base of e. So I can rewrite this as e to the exponent, x minus 2 equals y plus 4. That's just rewriting in exponential form. And now I get y by itself by subtracting 4. E to the x minus 2 minus 4 equals y. Notation, and we're done. F inverse of x equals e to the x minus 2 minus 4. Okay. So again, isolate the log first before you rewrite it in exponential form. But understand that an inverse of a log is an exponential. So whatever that base of that log is, that'll be the base of your exponent. Okay, so I hope this video helps. We will see you in class on Thursday. All right, thanks for watching.